All right. Today is your last day of e-learning for the week. It's Thursday, April 9th. Just a note about your tests. You had till 11:59 on the 8th to finish them. So I will get started grading those today, and they'll be posted sometime over the weekend, hopefully um, Friday. Just for your information, just like your test it would be in class, you will be able to do a retake on this, but that information will be available to you next week. All right, today what we're going to do is start our next unit, which is going to be all about logarithms. And we're going to spend the first couple days looking back at exponentials because all logarithms are inverses of exponentials. So if you remember before we went on spring break that now turned into e-learning, we were talking about inverse functions, how we just switch x and y. That's what happens with a logarithmic and exponential function, that they're both inverses. So today what we're going to look at and try to set the stage for the first couple days is why we need logarithms in the first place. Like, haven't we done enough with these exponentials? There's one thing that we haven't done yet. We haven't had to solve for the exponent. So that's what we're going to look at today, and we're going to start pretty basic. And then we'll move on to ones that maybe require logarithms a little bit later and add some challenge to that. But today we're not even going to worry about what a logarithm is. We're just going to look about how we can solve for the exponent. All right, so if we have this equation, and again, I'm trying to pick ones that are fairly straightforward to us. We have 4 to the x power is equal to 16. So you guys can solve this without a logarithm, but we'll learn how to do it with those later. We're just trying to figure out, whenever we solve an equation, we want to find the value of x that makes it true. So 4 to what power is 16? Well, we all know that 16 is 4 times 4, and that is equal to 4 to the second power. So we're not going to be, because we don't know our inverse operations on this one, we're not going to be able to use inverse operations. We're going to have to kind of make each side of the equation look the same. So this is telling me that our x value for this particular equation is going to have to be 2. All right, let's look at another one. So here it's 4 to the y power is 64. So what we want to think about is if we could rewrite 64, which we know is, right, 8 times 8. All right, but that's not going to help us in terms of our base of 4. If we think about it in terms of 4, 64 is 4 times 4 times 4. Or I could rewrite this as 4 to the third power. So again, y is equal to 3. So to start off with here, when we're solving for exponents, rather than just trying to do inverse operations, because we haven't learned about the inverse yet, we're just trying to make the left side and the right side look similar, write them in the same form. So since this is a 4 to a power, we're going to try to write that as 4 to some power, or how we multiply by 4 to get that. Let's try another one. All right, we have 4 to the z power equals 1. So what could we raise 4 to so that we get 1? So I'm trying to put a number here to get 1. Well, remember that any number to the 0 power is equal to 1. So for this one, z is going to be equal to 0. All right, let's try another one. Okay, 4 to the a power is equal to 2. Well, let's think about how I could get 2 by doing a power. Remember that the square root of 4 is equal to 2. So we're going to rewrite this as an exponential. Anytime we take a square root, that is taking it to the 1/2 power. All right, remember that this is 4 to the first, and there's that index of the radical that we could squeeze in there, and if it's not there, it's a 2. So that means for this particular problem that a is equal to 1/2. So these are a different way that your brain has to think, and just trying to see if you can work it out. And as they get harder, this sets the stage that we might need another way to figure it out. All right, let's try this one. We've got 4 to the b power is equal to 1/4. Remember that that's 1 over 4 to the 1. So if I want to write this with a base of 4, remember that a negative exponent takes it and moves it to the denominator. So this is the exact same thing as 4 to the negative first power, which means b is going to be equal to -1. All right, and again, these are challenging, so we're going to try our best. We've got to get our brains thinking a little different way. All right, if I look at this one, I've got 4 to some power equals 1 over 16. So if I start with that 16 and turn it into 4 to some power, well, 16 is 4 to the second. Look at that first problem up at the top. So this is the same thing as, if I don't want to write it as 1/4, 1 over 4 to the second, that's the same thing as 4 to the negative 2. So that means C is going to be equal to -2. All right, one more. And this one's pretty challenging. When I look at this one, I've got 4 to the d power is equal to 8. All right, this one's hard. This one we might really want that ability to do a logarithm for, but we're going to try it without here. The problem of why this is hard is I can't rewrite 8 as 4 times itself. 8 is 4 times 2. So therefore, what I have to think about is maybe changing my bases, changing the 4 into something else. So what I could rewrite 8 as, 8 is 2 times 2 times 2. So this is the same thing as 2 to the third power. And if I look up here, there is a way that I could rewrite 4 as 2, right? If I look at this, 4 to the a power is 2, the square root of 4 is 2, so a is 1/2. So if I think about a way that I could look at figuring this out, I can turn that into a 2, or I can think about a way to rewrite 4 in terms of base 2. It's 2 times 2, or 4 is 2 squared. So another way to write this 4 to the d power is the same thing as writing 2 to the, so there's 4 right there, that's 4 to the d power, right? So now if I think about looking at my exponents and setting up an equation, I end up with 3 equals 2 times d, and 3 over 2, or to the 3/2 power, is what our d is going to be. All right, so these are challenging. We're going to give you ones that work out nicely to start off with, and then once we learn a little bit more about how logarithms work, we'll do ones that may be more like this one on the bottom. All right, but we can figure that one out with our knowledge of exponents as they are, but logarithms are just going to make this easier. I'm going to show you one more way that we can do this and kind of talk about some different things. If I were to graph just 4 to the x power, all right, let's think about some things with respect to that graph and how we could use the graph to solve maybe some of the harder problems if we look down here. So determine the domain and range. All right, I don't need the graph to figure that out. You guys just took a test on this. Hopefully we know that the domain, remember that that's going to be all real numbers. We can plug whatever number we want in for x. But if we look at the range, remember that 4 to the x power can get really, really small, but it can never be negative. So our range is going to be that y has to be greater than 0, or if you like interval notation, we could go from 0 to infinity. All right, determine the horizontal asymptote for this one. Since there's no vertical shift, it's just going to be at y equals 0. So is the function 1 to 1? This is old stuff that we had before. What it means for a function to be 1 to 1, it means that each input only has one output, and each output is only going to have one input. So if I'm minimize this a little bit so we can look at Desmos. All right, so if I'm pulling up Desmos, then go ahead and graph this function, because if I try to do that on my computer screen, it's going to be pretty bad. I'm going to go ahead and change my labels so it numbers by 1 and kind of look at the graph and hopefully make it make sense of what we have on the screen here. So when I'm looking at, hopefully we can see that there's our domain is all real numbers. All right, if I zoom this out, it would go forever left and right. But our range, there's going to be nothing below that x-axis. On that horizontal asymptote, I could put it on there. It is just going to be the x-axis. It's going to be at y equals 0. Let me go ahead and get a different color for that so that you can see it. So there's our horizontal asymptote. And then the last question here that we were going over is it 1 to 1? All right, to be 1 to 1, it has to be a function, and its inverse has to be a function. Each input has one output. Each output has one input. It has to pass the vertical line test and the horizontal line test. So this is what we would call a 1-to-1 function. All right, so if we're just kind of reviewing, because this is going to come back, I want to fill, is this function yes, it's 1 to 1. The inverse is also a function. So here's what I really want to show you with the graph. I want to refresh your memory about what they look like, but I also want to think about how we could use the graph to find the answers to some of the questions that we just did. So if I go, wrong thing, back to this, and let's think about the problem that we had, the very first one. It was, when is this going to equal 16? So if it's y equals 4 to the x, if I put in the line y equals 16, all right, and move my graph, I can look and figure out, if I were to go back one slide, remember our first answer was 2, that when x is 2, our output is 16. All right, what were some other ones we wanted to know? We wanted to know when it would equal 1. And remember that answer was when it was 0. All right, when would it equal, the hard one that we did was 8. And then I can go here and figure out that that answer is 1 1/2 or 3/2. So I didn't ask you to do these two that you can kind of see here. All right, I wouldn't ask you to do these without using a graph or another ability to do this. So let's say I wanted to solve 12. All right, if I put 12 in there, I can see that, and it's Desmos isn't going to give me an exact answer. I'm going to have to round it, that the output is 12. So 4 to the x is equal to 12 when that x value is 1.792. All right, so that's going to happen when x is 1.792. I'm not going to get a nice answer like I did for the ones on the previous page. If I look at the last one here, when is it equal to -8? And I don't really need this to figure it out, but I want to show you. If I pull down here and adjust my zoom a little bit, all right, here's my line. Remember, nothing on this function is getting below 0. So we're going to have problems like this that have no solution. If we look at what we are wanting our output to be, this is asking for the output to be negative, right? It's asking for y to be -8. And we set up here that y always has to be greater than 0. So not all of these are going to have a solution, all right? Some of them are going to have really nice solutions. Like, for instance, 4 to the m power equals 16. This one has a nice solution because we know 4 squared is equal to 16. Then we know that m value has to be 2. Some of these aren't going to have very nice solutions, like 4 to the x power equals 12. It isn't a nice integer to get our answer. And then sometimes we're going to have things that have no solutions. For instance, if what we're trying to get for our output happens to be outside of our range. All right, so here's what I want you to try. And I know that these are challenging, but do the best you can. I want you to try the practice that is linked on Canvas for today. All right, and we will go over frequently missed questions and add a little bit more to this when we come back together on Monday. Have a great weekend.